you were to chase me around the lab, it would seem like I'm always running around doing things. But what you wouldn't see is that I actually spend a lot of time thinking about the experiments that I'm doing and then planning them out and then processing them afterwards. So it can be really exciting to dive into experiments, but if you don't plan them out thoughtfully and if you don't analyze them thoroughly, then you're not taking the most advantage of all that busy work time running around the lab. So today I wanted to talk about how I kind of deal with managing experiments and really stepping away from the bench and taking a bigger view to see how my experiments flow together, if I see any trends, and that sort of thing. So it can be tempting to wait until you have a report due or you have to give a presentation in order to do this sort of analysis, but it's really, really important to do it along the way, and it's a good habit to get into when you start doing research.
So I seriously think that thinking is one of the most underappreciated parts about actually doing experiments. And so I know firsthand there can be this feeling that you need to constantly be doing wet lab stuff. This could either be because you feel this like lab pressure, not necessarily from your lab, but this like lab guilt where basically you feel like you're not producing enough. You need to be getting more experimental results, and you can't get experimental results thinking. But as I'll show you, and I'll talk about, you can't get good experimental results if you don't think, and you can get good results more efficiently if you think. And so thinking is this really important thing to take into account. And thinking is work. Do not feel guilty about taking time to think. This can be the most efficient thing, the most cost saving thing, the most time saving thing. Because if you set your experiments up properly and you set your experiments up with the best ability to actually get the answers that you want, maybe even you'll discover when if you're thinking about looking back in your experiments, oh, I could try this and maybe this will, so like, yeah, I had this taught to me when I was in grad school. I had a great mentor in law, and he saw I was like working like crazy, like trying to do too many experiments at once, and he was like, "It's okay. Like step back, take a second, and plan these out more thoroughly." And that's totally okay. That's totally great. That's what you should be doing. And so having someone tell me that was really important. So I just wanted to tell that to you. Like, don't feel like you need to be constantly doing when you can be doing and still be doing. But of course, the experiments are really important too. And so we need to factor that in. And therefore, you need to find what works for you in terms of how to do this step back and think. So it shouldn't be just when your report's due or you have a presentation. It should be something that's like a consistent thing throughout the process, throughout all of your research. You need to be taking time to think about your experiments, to plan them out, to process them afterwards. I think this processing part is really, really important. As I'll talk about, it's really great to compare your experimental results like over time, look for trends and that sort of thing. When you have a lot of experiments planned, it can be kind of like you just feel like you get one experiment done and then you're exhausted, and then there's another, and you're exhausted, and another, and you're exhausted, and then you kind of like just are doing and not thinking in between about how these experiments relate to one another, whether and you kind of maybe you get behind on your note keeping, which is really, really bad because you really need to keep those notes up to date. But so you need to be taking time to take all of this into account. And so this can be finding some time of the day that works for you. So you want to at least keep your notes up to date for the day. But then you should be also periodically, like maybe once a week, going back and actually doing a thorough, like looking back on your results, comparing them, contrasting them, and that sort of thing that we'll talk about. Um, and so for me, what I do is I use the morning. So I get up at 4 a.m. I know yeah, but I get up at 4 a.m. And I work on my notes and things like that. And this allows me to kind of process things at the time of day when my brain works best. And I plan things out, and then I go do my experiments. After the experiments, at the nighttime, that's typically when I then write up my notes for the day, or at least the type up version. And then I do like processing and like trying to plan out my next sets of experiments. And then I can look at the experiments I planned the next day to make sure that I have everything planned out. And sometimes these experiments will take you more than a day to plan, and that's fine. Like you should take all the time you need in order to make sure that you're setting up your experiments for success. And so before you start an experiment, you want to make sure that you take your time and plan it out really, really carefully. One of the things that I stress over and over and over, because I feel like this is such an important thing, and I've seen based on like talking to some people, like some undergrads and or early grad students, or also like reading some application forms. It's totally normal, and I had to be told this too when I started out, that you need to make sure that you're knowing exactly why you're doing what you're doing in every step. And so on applications, if you're saying like I did this, I did PCR, I did this, I did this, why? Why were you doing this? What was the goal? What did you want to find? What did you find? Even if you didn't find something like crazy, you must have learned something along the way. And so know why you're doing what you're doing. What is that you're trying to figure out? And I actually write this down in my experiment, like in my protocols and my plans for an experiment. I specifically write like goals, and then I write out why I'm doing this experiment. And then you should know like what are each step does. If it's a kit, look up what each of the steps in the kit does. You want to know like why you're doing what. And this is going to help you if you need to troubleshoot or that sort of thing in terms of knowing what each step does. Um, Maybe you can optimize various things. Another really important thing when you're planning out your experiment is to make sure you have all the controls that you need. And so in it can get when you have like a lot of examples, say, or you have done this experiment a bazillion times, or a similar experiment a bazillion times, it's like, oh, I can just skip the control, like whether it's a negative control to make sure that there's no like contamination, or that this, so if you get a signal, you want to make sure it's actually a signal coming from what you think, and then a positive control so that if something is there, you can detect it, that sort of thing. Um, if you don't have these controls, then whatever results you get, you don't know if you can trust them if they're positive. If you get a positive result or you get some numbers, I don't know it depends on what experiment you're doing. But if you get some result, you don't know if it's legit if you don't have your controls. And so sometimes, okay, this is okay, like okay, not really okay, but if it's not an experiment you're going to publish or something, you might not always include every control that you need, especially if you've done an experiment a bazillion times. But when you're starting out, like troubleshooting of an experiment, especially, you really need to make sure you have those controls, because then what happens if something doesn't work, if you get a nothing result, or if there's just some weird result, you don't have those controls to know like what step along the way things might have gone wrong. And so it's important to have these controls. And if something does go wrong, if you do get a weird result, you need to know what each step did in order to try to figure out where something went wrong. What steps are you able to test? Those, then you develop a hypothesis. Okay, I think in this step this was the problem, and then you change that, and then you test again. So you really need to know what you're doing, and you really need to make sure that you have all of the information that you need to know what you're doing. And so you don't want to have to redo an experiment that didn't work because you forgot to include your controls, or to redo an experiment that did work because you forgot to include your controls and you need those controls. So always make sure that you have your controls. And if it's something where you need to subtract out like background to get like a treated sample, you need to have an untreated sample in order to compare it to. So much more on experimenting in other posts. But yeah, make sure you have those things. Make sure you really think out what different things that you need, so you're not halfway through the experiment and realize that, oh, I don't have my control, or oh, I don't have that chemical that I need, or I'm out of tubes. So you want to make sure that you have all of those things too as well. I really like to plan things out in my head ahead of an experiment. Like I'm constantly thinking about the like walking through things in my head, kind of visualizing it. I'm I'm one of those people too where sometimes the best, I talked about like stepping back from the bench to think. And sometimes like going for a walk, I like to like walk up and down the stairs and just kind of think. I find that like being in motion helps my brain to kind of just be able to, I don't know, not get distracted by like moving and stuff because I'm moving the same, I don't know, but kind of like having your body kind of doing something kind of makes it so that my brain can kind of process things. I don't know. But anyway, if I'm doing something else, I'm often like that's when like things like pop into my head. So it's really important too to not just be doing experiments all the time and not just be like purposefully thinking about science all the time, but allowing your brain a little bit of relaxation. And sometimes then is when you can actually like have the best ideas. What I find really unfortunate is that one of the times when I do like my processing of my experimental results is on the weekends. So I'm not advocating that you work 24/7 at all. But because I do a lot of things, I find that a couple hours on the weekends, maybe, just of like computer work. And so I do a lot of my post experiment processing over the weekend because I have more time without having to like worry about a timer going off, and that sort of thing. I like to kind of compartmentalize my time when I want to do like a deep review, like step back and think. I find that kind of like having that separated from the actual lab experience can be really helpful. If your boss like is okay with you like working from home, working from a library or something like that, take a few hours or take some time and just do it wherever you're able to focus best. Okay, so when you're doing this reflection I've been mentioning, I'm not talking about just a single experiment. So you should be doing that like after every experiment, you should be looking back at that experiment, making a summary. So remember how I said like before an experiment, I write down my goals. Well, after I do like a summary as well as a more detailed write-up. This way, when I look back on my notes, I can say, okay, like right away, I know what I did that day. And I know like I processed that experiment. Like I interpreted it. I didn't just do it. I did it mentally as well as physically. And so, but then you also want to be able to look at your compilation of results. So you're not just doing one experiment, you're doing a bunch of experiments. Maybe especially when you're like trying to optimize something or troubleshoot something, you're going to be doing a very similar experiment over and over and over. And you don't want to just do the same thing over and over and over if it's not working. So each time you're changing something. But unless you're like really comparing the results when you change something, you don't know, like maybe there was something there that was also there and that there and there and there. Or maybe you'll see like, oh, there's a weird artifact in all of these, but not these. Or, oh, look, it's getting better. That's the hopefully. But you want to be able to see these, and in order to see this, you want to make your life more easy so that you can compare these side to side. And so what I do is, so I have like a pen and paper notebook, and then I also have a digital notebook. What I do is during my experiments and everything, I write down on the pen and paper, then I take pictures and I type everything up, and I also put the pictures into my notes, and then I put the pictures into a picture file and my folder file and my desktop. So basically I have everything a lot of different places. But I don't like I like being able to write when I'm in the lab and my hands are all gunky and stuff, without having to like type up on my computer. But I do like having that digital form because that's going to allow me to search more easily, and more easily compare things. What I like to do is I like to make figures. So I organize my notes where I have like it by date, but then I also have like a to-do section, a figure section, and a protocol section. And so in this figure section, what I do is I actually like pre-format some of my figures from my experiments. And so like the figures that you would put on in a paper, I like to put kind of put like map out my pictures or format my data, label the lanes and everything. If it's a really important experiment or something I might want to actually be presenting in at a meeting or like a lab meeting or a real meeting or putting in some sort of report, then I'll put a lot more detail. But even if I'm not, I'll still format things up nicely, and with the basic information, the date, everything labeled. And then I'll keep these together in this figures spot folder. I've talked before about how this is useful, because then if you say you need to use that, you have a presentation coming up, you have that right away. But it's also useful because now I have all of my experiment figures, so all of the results, like right right next to each other, and I can easily compare and go back rather than having to dig through my notes. So I find this really helpful. In terms of the making those figures, I use Adobe Illustrator. A free alternative is Inkscape. These are both vector graphics programs, which means that they work with like points and things like that, and lines, and so it's kind of telling the computer where to put various points, and then therefore the computer can like mathematically make that whatever size that it wants without getting all pixely. Of course, if you have an image in there, so if you have like a PNG or a JPEG, some sort of picture of your gel, well, then if you blow it up, it's still going to get all pixely. But in terms of lines and text and things, they won't. So this can be really great. So I typically save my things as PDFs. Yeah, so, and make sure that when you're doing an experiment, like as soon as it's over, make sure you have everything written down. Even if you're not able to type everything up, or even if you don't have a digital notebook or whatever, just make sure you have the information you need, even if that means taking pictures of notes on the back of it from your gloves and paper towels. But make sure that you get that information down when it's fresh, and then you can type it up, you can write it up nicely. And then you can plan your next experiment accordingly. Don't just jump right into the next experiment without processing that for that earlier experiment. Sometimes it can be easy to get a little behind, and you want to make sure that you don't get too far behind. So maybe you go a couple experiments and then you really process them. But especially if one relies on the one before, or then you really want to make sure that you're taking the time that you need before you actually dive into that next experiment, no matter how exciting it is. You need to make sure that you always have your notes thorough and up to date. No matter, so that could be different ways that work for different people. Find what works for you. In terms of actually like protocols, so say if there's this, you have like protocols for an experiment. Typically, if it's a protocol that you get from somewhere, it's not going to be that detailed in terms of what you actually need to do. And so you're going to have your own notes. So like to write up detailed protocols. So annotate those protocols, make notes, make it so that if you were to give like a protocol that you would want to get someone to have given to you, if you had to do it like quickly and didn't have time to go through and figure out all of the various nuances that you would need to do. So I like to save all these protocols in like a central location. What I do is I have like Word document versions of them, and then I can be working with them. And I take that protocol, and when I have some variation of it, I work with that protocol, and then I type my notes into it. I print that out, and I take that, use it when I'm doing my experiment, make notes on it if I change things, and then I can incorporate to my notes. You shouldn't just be like comparing your results to your own results. You should be comparing your results to like published results if they're available. Especially if you have or maybe some problem comes up. You're not alone. So one is like talk to your lab mates. It can be hard sometimes if depending on your lab, maybe you feel kind of like there's no one to talk to. Hopefully you're in a really good lab where everybody is really helpful. And so I'm in a really great lab, and one of the things that my PI does, which I love, is that we have these like bi-weekly meetings. So in addition to group meetings, so group meetings can be a really great opportunity to get feedback on your results and things, but they're typically a little more formal, and you're often only giving them every like couple months or so, depending on how big your lab is. We have these bi-weekly group meetings where every other week we meet like a smaller subgroup of people who are researching similar things. And this is more just kind of like a chat with friends. And so we're really going over the experiments at the level. We just sit down and talk about where we are with our experiments, what we're doing, what we did, what we plan to do next, what problems that we're having, and then we kind of like can group discuss things together and kind of help each other out. And you can also be doing that like non-formally, even without the boss telling you to, all the while. So I'm constantly talking to my lab mates, kind of troubleshooting, thinking things through with them, and it's really, really helpful. In addition to having those like biweekly meetings, we have to give like a written thing too, just like just like bullet notes and bullet points and things, not like a formal report. But this is also helping make sure that we're actually taking time to think about our stuff and to have some sort of documentation without needing to wait until you have something due, like a official like presentation or publication or anything like that. It's always good to have kind of like stepping stones along the way. That also helps you when you're looking back. Okay, but now let's say you had some problems and no one in your lab knows, or maybe, I don't know, whatever. So Google is like a seriously great source. So you might think, okay, well, people, when they talk about scientific literature, they talk about like PubMed and things like this, like, oh, I'm gonna go search PubMed. I find it's a lot easier to search Google and like Google take you to the articles in PubMed. So PubMed, if anyone's unfamiliar with it, it's like the NCBI or something, like one of the National Centers for Biotechnology Information or something like that. Anyway, it's like a repository where they have information of all these like scientific articles and links to the actual articles. And so when you Google something, it'll often take you to PubMed, but it'll also potentially take you to things that aren't in PubMed that can also be helpful, things that maybe are on a preprint server. So they haven't been through peer review yet, or they're on some sort of protocol website or something, which can also be really helpful. So don't be afraid to Google. Scientists Google all of the time. It doesn't mean that you're not a scientist. It probably means that you're more of a scientist if you're comfortable with using Google. So don't feel like you're not a serious scientist or anything like that. But anyway, if you had problems with doing something, you can be searching the literature for that. I'm also trying to find alternative methods. So you can search based on the methods if you're having a problem with the method, or based if on like what you're trying to figure out, if that's what you are. So be okay with knowing that you might need to change your experiment plans a little. And that's another reason why it's really important to know what each step is doing and what your purpose of the experiment is, what your goal is. When you're searching the literature, so with Google search, that like plus sign is really helpful for making sure that it does like both of the terms that you want it to look for. And you want to be really, really specific. If you find an article that you find helpful, make sure that you save it to your reference manager, like Mendeley or EndNote, Zotero, one of those things. I talked about a lot more in another post, but make sure that you have that saved so then you can go back and you don't have to do this whole thing again. Often the best stuff about, especially methods wise, is in the supplemental materials. And they often have like supplemental discussions, which is kind of stuff that's either they had to take it out of their main paper because it was too long, or maybe the reviewers had asked them something and they didn't want to put it in the main paper, so they put it in the supplemental. Often the methods these days are like all in the supplemental. Basically all the good stuff is there a lot of times when you want to know like inside the head of the scientist that did things. So sometimes if they do a method, say, you might be wondering, okay, well, why did they do it that way? Why this way seems like it would work. This way I want to try seems like it should be a really great idea, right? But maybe if you look in that peer review files, the reviewer would have asked, like, why didn't you do it this way? And the people might have a really good reason, like we tried and it didn't work. And so these are important things that you need to know. So you can also often find some really great like stuff if you do some sleuthing. But you should always be doing some sleuthing in your own stuff. So make sure that you make the most of all of your experiments. Make sure that you don't waste any unnecessary time, effort, or money. Science, you make a lot of mistakes, and it's totally normal. So don't feel bad if you make mistakes. Everybody makes mistakes. It's one of the best things about science, is that everybody's really understanding that sometimes experiments don't work, and sometimes experiments don't work for something that is like nobody's fault. Sometimes things don't work for reasons that could be avoided, and so you want to make sure that you try to avoid as many mistakes as you can, give your experiments the best chance of success, and then like process them and make the most of every experiment that you do. And remember that thinking things through beforehand is going to help you in the long run to have the most effective experiments. If you do rush into doing an experiment and then you have to redo it, well, now you've wasted time, energy, money. If you plan it out well beforehand, then you have a better chance of being successful. And if you actually able to process all of your experiments and kind of put things into perspective, compare and contrast, you're going to be able to plan better experiments so that you don't have to then do more experiments. So I love doing experiments, but I love doing experiments that are going to give me the answer that I want in a way that I'm then not I don't have to repeat the experiment. Instead, I can move on to the next cool experiment based on the results of this experiment and things like that. So you just really, really, really want to be thoughtful, and this is just a good practice to keep to start early on. Make sure that you develop these good habits